This is the question from GATE 2022 and the question is, an inductor having a Q factor of 60 is connected in series with the capacitor having Q factor of 240. The overall Q factor of the circuit is, round off to nearest integer. We have to find out the overall Q factor. What do we mean by Q factor? Q factor is nothing but the quality factor. So we have to find out the quality factor of the complete network. Here the circuit. What is the circuit? The circuit is having the inductor and the capacitor, which is having the different Q factors. For inductor, the Q factor is given as 60, and for the capacitor, the Q factor is given as 240. And these two are connected in series. So what will be your diagram representation? This is your first. For inductor, the Q factor is given. So this first Q factor, let us say this will be your Q1. So this is your inductor. Inductor is nothing but we are having the resistance and the inductance. That means we are having the coil here. So here Q1, or you can denote QL for this inductor. This is one Q factor. Next, it is given that the capacitor Q factor. Capacitor means again it will be the lossy capacitor. So lossy capacitor means resistance and capacitor are in parallel. This is for the capacitor. And here the Q factor we are denoting as Q2, or you can denote as QC. So this is for coil, or you can say inductor, and this is for capacitor. Now these two Q factors are connected in series. So this is the series connection. We have to find out the overall circuit Q factor. So we have to find out the total Q. We know one formula for the Q factor, that is nothing but Q is equals to QL into QC divided by QL plus QC. This is the formula we already know. This formula, how you will find this formula? This formula, this is find out from the transfer function and the zeta value, where the zeta value will be 1 by 2Q, and from that you can get this formula. So no need to go in the detail how we derive this formula. We already know this formula, that Q is equals to QL into QC divided by QL plus QC. Now here you can see QL is nothing but your Q1 and QC is nothing but your Q2. So here we are replacing as Q1 into Q2 divided by Q1 plus Q2. Now we know the values of Q1 and Q2. What is the value of Q1 here? The value of Q1 will be 60 and the value of Q2 will be 240. Directly substitute the values. That is 240 into 60 divided by 240 plus 60. So it will be coming out as 48. So the overall quality factor for the complete network, where the inductor and the capacitor are connected in series and their Q factors are given. So by applying the formula that Q is equals to Q1 into Q2 divided by Q1 plus Q2, or Q is equals to QL into QC divided by QL plus QC, we can directly find out the overall circuit Q factor, and that will be coming out here, that is 48.